Hello everyone, welcome to my 100 most popular algorithm series. In this video, I'm going to cover Leetcode problem number 74, which is search a 2D matrix. It's a grid-based problem. It's a medium category problem. So the problem statement goes like this. So here we're given a grid with the two special properties. So grid, the length can be m and n. So they are not same. They can be any length and any breadth. The properties of this matrix, there are two properties. One is every row is sorted. So every row is sorted, and then the first integer of each row is greater than the last integer of the previous row. So that is the two special properties of this grid, and we are given a target, and we need to write an efficient algorithm to find that target in this grid. So a very non-efficient algorithm could be a brute force approach, where we just basically check every cell of the grid and then figure out this target is present or not. But we are going to write an efficient algorithm. So let's discuss the algorithm here. So let's say our target is 3, and this is the matrix that we are given to us. So we'll start searching from this location. So by and large, this solution comprises of two steps. First step is to figure out the potential row in which this target could be present. Now once we've narrowed down that row, then the next task is to do the binary search on that row in order to find the exact location. So in order to find a potential row, what we need to do is we need to start from this location and we'll compare the target. If the target is less than or equal to this particular item, that is the element at the end of the row, if it is less than that, in this case it is the case, right? 3 is less than 7. So we know that 3 could potentially be in this row, and hence we will perform binary search on this row. If the target would have been, let's say, 30, then what we'll do is 7 is greater than 30, so we know the target cannot be in this row, so we'll move to the next row. The target can also not be in this row because this is 20 and this is 30 is greater, so we'll come here, and now we know that target could potentially be in this row, so we'll perform binary search on this particular part. So I hope you understand the approach. Now let's begin coding of this problem. So first we'll do some sanity checks on the inputs. So if the matrix is not present, or there are no rows in the matrix, or there are no columns in the matrix, then I'll return false. Okay, now I need two things here. I need a row which will be floating, so we'll start from 0. We'll start from 0 and then we'll keep on going down. Column will remain the same. Column will be, we need to perform our search on the last column all the time, right? So the columns will be the same. That's the last column index. Now while row is less than I missed this check. Yeah, so that's the first row and the last column. Now while row is not exhausted, we need to do this check. So if the item at this location, the element at this location, let's say if by mistake we stumbled onto the actual target, then we'll simply return it, right? There is no point doing binary search because we know that we found the target. So we'll do that check first. So if somehow we've stumbled onto this target, the target resides here in the last column, then we'll just return true, we have found the target. If that's not the case, then the second check is if this number is less than the target, then we know that the target could potentially be in this row, so we'll break this iteration. Otherwise, if both the conditions are failed, then we'll have to move to the next row. So we'll increment the row and continue this search. Now it may so happen that we have exhausted all the rows and the target is still greater than the last element, which is 60. Now that can potentially happen. Okay, in that case we'll know that we do not have that target present, right? So we'll straight away return false if we have exhausted all the rows and we've reached here. Okay, so now the solution up till now is we have figured out the row, which is in this variable that we know. After this logic, we know that which row the element could potentially reside. Now we need to perform binary search on that. So now I'm writing the classic binary search variables. So we need start and end. Start will point to the first column, which is 0. End will point to the last column, which is this one. Okay. Now again, this is a typical binary search skeleton. So I'm just writing that. We need to compute mid every time. So mid is equal to start plus So in binary search, we basically reduce the array space, search space by half every time. So first we need to compute the mid, which is this. Then we need to figure out, we need to figure out whether we have found a target at this location or not, right? So that check we need to perform. So we'll do matrix. Now row is the same. The row is not changing, but column is defined by mid. If that is equal to target, then we will return true. Okay, if the target is not found, then what we need to do here is we need to reduce the search space by half. So we can either continue searching on the left hand side or on the right hand side. So that will be decided based on this condition. So if this element is less than target, let's say we are required to search 3 and we reach tier 1. So we know the target is on the right hand side because this element is lesser. So I'll adjust the start in that case, which is equal to mid plus 1. Else I'll adjust my end, which is equal to mid minus 1. Okay. So hopefully this entire binary search should be able to figure out the target. If at all it is not able to figure that out, then we know for sure that the target doesn't exist. So we can just straight away return false in that case. So yeah, that is the code that we need to write. Let's quickly check our cases. Oops, something went wrong. Let me verify the solution. I've started with row 0. Column is that? No. Yeah, that is correct. While row is less than length of matrix, that is also correct. If matrix row equal to target, we found the target and we return false. If this element is less than the target, then we'll break. This is the wrong one. This is greater than the target, then we should break and then we'll continue. My bad. Let me run this code again. Yeah, it worked. Okay, let me try searching something else. Let's say, for example, about 11, second row. Yeah, it worked. How about say 23, third row? Yeah, it worked too. How about, let's say I'll try some element on this last column, which is 20. Yeah, it worked. Let's try for non-existent elements, let's say 15, all the negative cases. So 15 is not present. Yeah, it's working. Let's try for 90, which is not present. So let's try 0, which is another corner case on the left hand side of the first row. Yeah, so let me submit a code. Hopefully it will get accepted. Yeah, it worked. So yeah, that's how you solve this problem. I hope you like this coding challenge. Stay tuned for more coding challenges like this. I'll see you in the next one. Bye.